Okay, let's start. Okay, I want to share my screen with you. I want to make sure that you have this handout on Blackboard. Can you see my screen? Yes? Okay, perfect. Do you have this on Blackboard? Let's wait for Tony. He's trying to reconnect. You do? Yes? Yes, you've seen it on Blackboard. I want to make sure that everybody has it, okay? So let's just review real quick. Common components of your IV bag, okay? And their abbreviations. Can you hear me? Okay, Tony, can you hear me? Yes?
Yes, ma'am. Sorry, I forgot my camera was off.
Yeah, I think you got kicked. Were you kicked out? Were you kicked out?
Oh, everybody just turn off their cameras?
No.
Okay, no, yeah, I left the meeting, but I forgot my camera was off, so it was my mistake.
Okay, that's fine. Okay, let's do this. A couple of things, okay? IV components of your IV bag, okay? Most common components and their abbreviation. When you see capital D, it's dextrose. When you see capital W, that pertains to water, okay? Capital S, saline. That's why NS, both caps, is normal saline. Okay, this is what I wanted to highlight after I've gone over all of this abbreviations, okay? Sodium chloride is Na, capital N, lowercase a, which is sodium, okay? It came from natrium, that's why Na, okay? And then Cl, capital C, lowercase l, is chlorine or chloride. When combined, we'll do this in chemistry, sequence 4. When combined, it's sodium chloride. We have Rl, which you've heard in pharmacology, okay? Ringer's lactate, or LR, lactated ringers. Okay. Something I'd like to highlight, okay? When you see an IV bag that says D5W, okay? Let me annotate. When you see an IV bag that says D5W, it pertains to, this was in my video lecture, remember? It pertains to dextrose, take note, 5% in water. Dextrose, 5% in water. Is the water 5%? Or is it the dextrose that's 5%?
The dextrose.
The dextrose is the 5%. You have to remember, this is an important fact. Water will always be 0%. Okay? There's no percentage for water. It's not too concentrated. It's not less concentrated. Water will always be 0%. You follow? Okay. I say a lot of things that sound so simple, but commonly, what? Commonly forgotten or common mistake. Okay. Trying to draw. Okay. So when you see dextrose 5% in water, there's a percentage sign. The 5% is the dextrose, not the water. Okay. It means that this IV bag, okay, a solution of IV, okay, a solution in an IV bag will have 5% of dextrose in it. Okay, water is 0. Water will always be 0. And what does that mean? If you want to picture it more in layman's term, dextrose is sugar, sodium chloride is salt. You follow? Okay. And I talked about in the 3 videos how percentage works. Remember? Percentage, when we're talking about concentration or strength of the drug, will always be, they will not specify all the time, but it will always be either grams over grams, ml over ml, or the most common grams over ml. Remember this? Okay, so, but what you see is just percentage. You didn't see here that it's grams over ml. It's just 5%, right? Okay, but you have to picture this as sugar getting dissolved in water. like a syrup. Okay, that's what dextrose in water is. Normal saline, though, is salt getting dissolved in water. Okay, so here we go. This you won't see, but know that strengths and concentration of drugs may come in 3 of these forms. And always remember that the grams on top is your weight of solute. Okay, let me talk about solute, solvent, and solution. Very, very important terminologies. Okay. Solute plus solvent equals solution. Solute is the substance to be dissolved. In this case, is it dextrose or is it the water?
Thanks.
It's the dextrose, correct? That's the sugar, okay? The solvent is the dissolving medium, the substance dissolving the solute. Can you follow? So which one is this in this IV bag? Kevin?
The water?
It's the water. And if you combine, it creates a solution, which is this IV bag, the solution in the IV bag. Can you follow? Now it's a sugar solution if we're going to talk in layman's term. That clear? Okay. So picture you're dissolving sugar. Yes, Adziri.
Can you repeat what you said about how
Solute, solvent?
Yeah.
Okay. So solute is the substance to be dissolved. So let's put some sugar in here in the bag. That's your solute, right? Remember I told you I'm old school pharmacist? We used to make IV bottles, solutions for IV bottles. And I would measure salt, put it inside the bottle, and measure the liquid, put it inside a bottle, seal it, and send it for autoclaving. That's how old school it got. Okay? That was my job before when I used to be in the hospital doing swing shift. Okay? So now they're in disposable IV bags. Okay. Going back, solute is your sugar, which is the dextrose, the substance to be dissolved. Then you add the water, that is your solvent, that is the dissolving medium, the substance that's used to dissolve the solute. When you combine the two, you make a solution. Okay? It dissolves into one phase. You only see the liquid part, correct? Okay. However, that's not always the case in pharmacy when you're combining substances. So when we're talking about dextrose 5% in water, we're talking about this percentage. Can you follow? It's the grams per ml because the sugar is solid. Can you follow? And then your dissolving medium is liquid. Okay, so it doesn't apply to the grams over grams. But if we're talking about ointments, creams, lotions, semi-solid, can you follow? They're both what? Weight.
Grams.
Okay, so it's going to be grams over grams. And I want you to remember this. Grams on the numerator will be weight of solute, and the denominator will always be total weight of the solution. Okay, so here on the ml over ml, this is the total volume of the solution. Okay, and the same here, total volume of the solution, not the solvent. Can you follow? Not the solvent. It's different. So Miss L, why are you calling it solution if it's solid form? So for here, we can make it compound. Total weight of the compound. Can you follow? But most common reactions, talking about IV bags, we will be using this percentage. Weight of solute, because D, dextrose, aka sugar, and sodium chloride, aka salt, are solids dissolved in water to make a solution, a sugar solution, or a salt solution. Can you follow? This is the basis. This was my video, okay? One of the first 3 videos. I was explaining percentage, okay? So we will be focusing more here. However, on the PTCE or the final exam, it's not always going to be focused here. You may be given an ointment or a lotion problem wherein you have to know that percentage formula for that is this one because it's semi-solid, okay? So Ms. L, where does the solvent come into place? Okay, the solvent come into place when you're asked how much solvent was added. Okay, because remember, the solution will be more than the solvent alone because it's going to be the dissolved sugar or the dissolved salt plus the water. Can you follow? So if you are to ask how much solvent was used, you're going to deduct the total solution from the dissolved solute. Are you following? That's why it can be complicated for some. Okay? But you have to know that the basis of your percentage is always weight of solute over total weight of solution, weight of solute over total weight of solvent, okay? Or ml over ml. I mean, volume of solute right here over total volume of solvent, okay? And then weight of solute over total volume of solvent. You have to remember, numerator is always solute, denominator is always solution, not solvent, okay? Another trick to do that, after you've done that fraction, you multiply it by 100. Or you can simply do, remember in my video, weight of solute in grams over 100 grams. Volume of solute in ml over 100 ml. So you don't have to multiply by 100, okay? Weight of solute in grams over 100 ml. And then you use your ration proportion. But you have to remember, another thing you have to remember, when we're talking percentage, it will always be grams for your units of weight and ml for your units of volume. And if they're not, it's given in liters. You have to convert before you get the percentage. I cannot be repetitive enough on this one. Sometimes drugs come in milligrams. If you need to convert to percentage, you have to convert it to grams first, because percentage will always be grams over grams or grams over ml or ml over ml. And this is how you're going to get your answers wrong if you don't follow this simple rule. Is that clear? Yes? Those 3 videos I have on percentage are very, very, very repetitive. Okay. Again, terminology, solute is the substance being dissolved. Solvent is the dissolving medium. Okay. The solution is a combination of the two. Now, Ms. L, I have a question. What if they're both solid? Okay. So whichever one, or they're both liquid. Whichever one is less is your solute. Okay. It's just easier terminology wise. Okay. Another thing I'd like to cover. Okay. Let's talk about this first, the dextrose 5% in water. I'm not good at drawing just like that guy that we had, okay? D5W, okay? This dextrose, this IV bag has 5% dextrose in water, okay? Say, for example, this IV bag is a 500 ml solution of D5W, okay? This is how you can simply calculate. Percentage, I told you, this one, 5%, I will convert this right away to 5 grams for every 100 ml. Why? I know that this is a sugar solution, right? And what did I say about percentage? You can break it down right away into grams over ml or grams over 100 ml. Simple. Ration proportion, what do I do now? Well, for every 100 ml of the solution, there's 5 grams. And this means that's 5%. But this IV bag is not only 100 ml, right? This IV bag is 500 ml. So now I want to know how much dextrose or solute is in this IV bag. It can be as simple as ratio proportion. You follow? Yes? Okay. So let's cross multiply. This will be 5 times 500 would be, where's my calculator? 2,500 divided by 100 would be
25.
25. So this tells you that this IV bag that is a 500 ml dextrose solution has 25 grams of dextrose or your solute. Hint, hint, wink, wink, PTCE, final exam. That clear? What if the given is 1 liter? How are we going to do this? This IV bag is bigger. 1 liter. What did I say? First thing you do is to
Change it into milliliters, which would be 1,000.
convert it to milliliters, which a liter is 1,000 ml. That's the first thing you do. So this becomes 1,000 ml. And then proceed with your ratio proportion. Okay? So without doing the math, using a calculator, just in your head, you know that 500 ml times 2 is 1,000. You double the solute, which means this IV bag will have 50 grams of dextrose, yeah, in this 1,000 ml solution. You follow? Yes? Okay. Another thing, Jess, you okay? Okay, I want to clear this. Powder displacement. This always comes up as a test too, outside of the IV bag. Okay. Let's talk about a drug in a vial that is in powder form. Yeah? Say this little vial. I'm not very good at drawing, okay? It has powder in here, okay? Which is what you're learning in IV, okay? And then it said on the label, okay, add, reconstitute is the term, yeah? That means add water or whatever diluent is required, okay? Add 9 ml of the diluent to make a final solution of 10 ml. Yeah? Doing the math in your head, when this powder is dissolved, if you're asked, how much is the powder displacement? What should be your answer?
1 milliliter.
Correct. Because powder displacement is the final volume of the solution minus initial volume of the solution, which is, this becomes a liquid form now, totaling 10 ml. And you added the solvent or the diluent 9 ml. Yeah? So your powder displacement is 1 ml. You follow? Powder displacement. Take note of the term. Powder displacement. Final volume minus initial volume. Okay? That's the amount of the drug after it getting dissolved. And this is what I was talking about. When does the solvent matter? If the question is, here's the final volume and the powder amounts to 1 ml, how much solvent did you add? It's the reverse now. So it's going to be 10 minus 1. Now you know that the amount of water or diluent added or solvent added is 9 ml. Can you follow? Yes? Stop me right now because it's going to get a little bit more complicated once we get to the normal saline. Is it clear? Yes? Freshman, Nicole, Adziri, Jess. You still with me? Yes. Okay. It's a lot of information.
You said
Yes,
it's
Robert?
final volume minus initial volume?
Yes. Which the final volume is 10. The initial volume was what?
9?
9. Okay, so your powder displacement is 1. It means that after dissolving that powder, it amounted to 1 ml. Okay, moving on. Okay, normal saline and sodium chloride. Very common mistake. A lot of people make, not only pharmacy technicians, but also nurses. Okay. Sodium chloride is a salt, which is a combination of sodium and chlorine. Normal saline is not the same as sodium chloride. You got to know this. I mentioned this many, many times in the videos, right? Normal saline, let me check if you know, is equivalent to what? Kevin?
Did you want the percentage or?
Yes, I want the percentage.
Oh, 0.9%
Very
of
good.
sodium.
Very good. Okay, 0. Do not forget the leading 0. 0.9% sodium chloride. So normal saline is not 100% sodium chloride. You have to know this. The reason I'm telling you this is because on tests, be it PTCB Exam final exam, they don't put that normal saline is 0.9% sodium chloride. So the terminology normal saline, right away, you should picture 0.9% sodium chloride. It's even less than 1%. Remember that baby who died? Who is that? Which baby is that?
Allicin.
No, that's zinc.
Mhm.
It is Emily's law, remember? Hers was sodium chloride overdose. Remember? Eileen, did you present that one? No?
With Nyla.
Okay, but you remember, right? Because the tech made an IV bag from scratch. Okay? So it was a over 23% overdose of sodium chloride. Okay? And you have to remember this. Normal saline right away, 0.9% sodium chloride. They're not the same. Normal saline is not the same as sodium chloride. It's even less than 1. I can't stress this enough. I had a student who externed at a detention center, Clark County Detention Center. And I remember her story, but she said there was a nurse, I don't know what kind of nurse, you know how we have so many nurses, right? Who told her that, why are you giving me 0.45% sodium chloride when the prescription says half normal saline, right? And she politely explained, she didn't become a smartass. She politely explained that normal saline is 0.9% sodium chloride. So a half normal saline would be 0.45% sodium chloride. You follow? See, she said, I was dealing with a nurse and this is what happened. Okay, no offense to the nurses. That's why I said, I don't know what kind of nurse. And a lot of times we encounter this over the phone in the hospital. Okay, a CC and an ML. You have to know that a CC is the same as ML. CC is usually used in Europe. Okay, but know that 1 CC is the same as 1 ml. Anyway, going back to this topic, because this is very important. If dextrose is sugar, okay, normal saline, okay, is salt solution. Others call it brine. So it's the same, except that it's a little bit more complicated for some because it's not a full percentage. Yeah? So if this is a normal saline IV bag, that is 500 ml, right? This means, let's start off with, there's 0.9% of sodium chloride in here, okay? And let's convert that 0.9% sodium chloride so you can picture it better. There's going to be 0.9 grams of sodium chloride for every 100 ml of this solution. Can you follow? Yes? That's your percentage. But the bag is not only 100 ml. What's the bag?
500.
500 ml. So ratio and proportion again, right? Now you can calculate how much sodium chloride or solute is in that 500 ml bag. So 500 times 0.9 equals 450. Tony, continue, divided by 100.
It makes it 4.5.
4.5 grams. So this IV bag, 500 ml normal saline, will have 4.5 grams of sodium chloride. And this was Miss L's job in the hospital, let me tell you. I have a 500 ml bottle, okay, capacity bottle. I will actually measure 4.5 grams of salt using a funnel, put that salt inside, and then fill it up all the way to the mark 500 ml. Not add 500 ml. You follow? Not add 500 ml. Fill it up all the way to the 500 ml mark because that's the total volume of the solution. And you follow? Yes? Uy. Yes? Yes? Oh my gosh. Okay, I said I'm not going to deal so much with percentage, but this is a lot of questions that we've been seeing on the PTCE. Percentage is a lot of questions on the PTCE. Okay, and this is going to be a major part of their job, especially if you work in an IV room, a hospital, or a specialty setting that does IV or sterile compounding. Is that clear? Before we can proceed to alligation, you have to master this. That clear? Okay. Did you have worksheets? Yes, on this one, the practice worksheets. Did you fill them out? It's only 5 questions, correct? And I want to go over it. Is this the one you have? Yes? Who answered this without problems? Hands up. Yeah? Who stopped? Because this is too complicated for me. I didn't understand. I watched the video 3 times. I watched it over and over, but it's still complicated. Kevin said he stopped. Kevin, let me hear this, okay? I always tell you guys, I want to listen to what your struggles are. So moving forward, I can help you better and I can help the future students. Yes, Kevin?
So I was stuck because, you know, this is all brand new to me. So I stopped for like maybe a good like 2 hours. I went to the gym, tried to clear my mind, and then I came back and rewatched the videos. And I'm hoping I did all of them right. You know, I answered them all, but I'm still like, you know, kind of iffy about how I did my math and you know, how I got things. But, you know, hopefully I'll get it better today, you know, that we're reviewing everything and discussing everything.
Very good. Okay. What about you, Adziri? I saw you raise your hand. You stopped at what point and why?
Well, I rewatched the videos, like you said, like 1,500 times, and it just
Just
looked
like you kept emailing me that it's not showing on your test. You keep refreshing. I like it. I like the perseverance.
It wasn't clicking in my head. Like right now that you were going over it, it started to make more sense, but I feel like I need more
Practice.
explanation because this is the first time I'm seeing this and I completely like foreign to me.
Right. Okay. But did my explanation help?
Yeah, so right now when you were going over it in the live, it made more sense than it did in the videos.
Right, because I got to draw the bag. You get to picture that, oh, this is sugar, or this is salt. Oh, it dissolves. But not all substances dissolve. How you have to know that? We have suspensions. Not everything dissolves, and that's what you're going to learn in compounding, non-sterile and sterile compounding, okay? What about you, Nicole and Jess, because you're both freshmen? Nicole first. Did you have to stop or you just watch the videos over and over?
I had to keep watching the videos over and over.
Yeah, but did it click now after the live?
Yeah, watching it in person helps a lot more than just the videos.
Yeah. Okay. Kevin went back and rewatched it. Let's see if Kevin got it right. If all he needed was rebooting and then come back and then do that again. Okay. What about you, Jess? My freshmen, of course, I'm always concerned with my freshmen. And of course, you guys are going to be jealous because I do favorites, freshmen and seniors all the time, right? So you will always be my favorite. There will be a point wherein you will be my favorite. But right now, it's always freshmen and seniors. So I call Eileen all the time to set a good example and make sure that she's on the expert level. And then I call the freshmen. Jess, what about you? How did it go for you?
Pretty much the same for me. I mean, I watched the videos, but it honestly was just so foreign that it was just kind of like, I had no idea what was going on. So I just kept on watching them. But now when you explained it like live, it's starting to click, but I feel like the same page as like at Zeri, where it's just kind of like, I need more guidance, I guess.
Yeah.
'Cause even when I'm looking at it right now, I'm still kind of like I just don't know where to put things.
Right. That's why I tried to do it ration proportion way so that it clicks faster and easier. Okay. I know this is foreign, especially to the freshmen. That's why there's no way you're going to get it by just watching my videos once. Can't be. Okay. Tony, did you have to stop?
Yeah, absolutely. And I rewatched them again and again, just like everybody. So I'm surprised that video hasn't blown up for you. Because I literally kept rewatching, and then it sort of came into focus, but it was tough at first.
Yeah, but percentage is a basis of a lot of the calculations. And that's why I wanted you to master it, not only for alligation, dosage calculation in general. And you have to know those repetitive grams over grams, grams over ml, ml over ml. Yeah. Percentages can be converted to decimal. Decimal can be converted to fractions. You can do ration proportion. Okay. Yes, it's Zeri.
I even rewatched the videos on the 15-minute break.
I told you, right? Refresh again. Because sometimes, especially if we struggle in math, we have to do it over and over, and then I'll draw. That's why we have worksheets. That's why we have this. Okay. Robert, what about you? Did it click right away?
No.
No?
It,
Okay.
it took me a while.
It took you a while. Okay. The terminologies will come up on your final exam as well. The solute, the solvent, and the solution part. Okay. Eileen, what about you? Let's hear it from the senior. She's so used to me now.
Mm-hmm.
The topic is new for her. Not the percentage, but the allegation will be new for her.
Yeah. But
So
we did this before.
The percentage, yeah. We did percentage, but the allegation, not yet.
Yeah. Well, I didn't really look at it yet. I was going to do it tonight.
Okay, yeah. But this is a good refresher for you. Did you have to rewatch the videos?
No, just look at my notes.
Okay, cool.
Yeah.
Okay, let's see. Everybody did this, 1 to 5 only. We'll finish right on time. Okay, I'm getting good at trying to finish on time. I think I need to adjust our time because I give you 15 minutes break. I might have to start 30 minutes earlier, or you expect me to finish 30 minutes later. Okay, especially with math. Okay, on Friday, my plan is to just do math all 2 hours to get caught up. Okay, and then Monday is going to be pharmacology if we get caught up with math. Understand? Because Tuesday is final exam. That's how I always balance it out. Okay, because now looking at your faces, I can see that there's still some confusion and I need to pump the math more. Yeah, do you agree? Yes. Yeah. Okay, let's do this. I'll do the first one. How many grams of sodium chloride, I'll encircle this, are in a 250 ml bag of normal saline? I just did it by doing a drawing, right? Well, we know right away that normal saline, like what I said, is 0.9%. So that can be converted right away to 0.9 G over 100 ml, because this means 0.9%. Yeah? So that you don't have to do 0.9 over 1 ml times 100. Do it this way. Done. Okay? But your bag is not 100 ml. Your bag is 250 ml. So this is your X grams. Okay. Don't forget, this is sodium chloride, not normal saline, because if you put normal saline, I will mark you wrong. You're just being asked of the solute. So cross multiply. Let's do this. 0.9 times 250 equals 225 divided by 100 would be 2.25 grams of, what will be here? Sodium chloride, not normal saline. So if you're asked how many grams of solute, it's only the salt being asked of you, not the solution. Who got 2.25? Hands up. Yes. Yay. Okay, let's see the ones who are struggling. Kevin, you're not that much struggling, but I want you to do this.
Okay.
Number 2.
All right. Number 2. So this is gonna be how many grams of sodium chloride are in a 250 ml bag of 1/2 normal saline. So we know that from the ratio of weights handout that half normal saline is 0.545% of sodium chloride. So we're gonna put 0.45 grams over 100 mLs equals what we want to look for in grams of sodium chloride. So it would be Xg over 250 ml, and then cross multiply, and you would get 112.5 equals X 100, and then you divide by 100. X equals 1.125 grams of sodium chloride.
Let me go back. How do I eraser? Oops, what happened? Okay. What is the final answer, Kevin?
1.125 grams.
Oops. Okay, here we go. It's going to be 1.125 grams of what?
Sodium chloride.
It'll be sodium chloride. Again, if you put NS, I will mark you wrong. Who got this one? 1.125, okay? You can actually change, you can actually end at 1.13, okay? But keeping it all is fine too, okay? Now, here we go, Adziri, to check whether you're, whether we're getting this now. Okay, number 3. I will be your secretary at this point. Tell me how you did it.
Okay, so for number 3, I don't know. Okay. I didn't do number 3. I didn't get that far, but I can I'll do it right now.
Okay.
So we need grams of sodium chloride that are in a 250 milliliter bag of the regular sodium.
Actually, it's a quarter normal saline.
Normal
So
saline.
what do you do if it's a quarter normal saline?
So it's going to be the same as 0.45 grams over 100.
No. 0.9, half of 0.9 is 0.45. But a quarter of 0.9 is not 0.45. This was Kevin's half normal saline. That's why he said it's 0.45. Right? Because 0.9 divided by 2 is 0.45. That's half. But a quarter would be 0.9 divided by 4.
Which is 0.225.
There you go. Okay? So this will be what? 0.225
over 100 milliliters.
Over 100 milliliters, correct. Equals?
X grams over the 250 ml.
There you go.
So then you multiply that by 250, which is 56.25. And then you divide by 100, which is 0.5625.
Of what?
of the NaCl, the sodium chloride.
Very good. Do not forget that it's grams and it's NaCl at this point. Okay, I can't be repetitive enough. Okay, now you following? Okay, take note, this is a quarter normal saline. Okay, some people just memorize half is 0.45, a quarter is 0.225. But if you're lost, if you know that normal saline is 0.9, just divide it by 2 if it's half, divide it by 4 if it's a quarter. Okay, number 4, Jess, let's see. I'm focusing on freshmen right now.
So number 4 would be 5 grams over 100 ml.
Very good.
And then equals X over 250 ml.
Okay, do not forget to put the G so that you know, okay?
Okay.
Tests can be tricky. They're going to give you milligrams. They're going to give you liters. You have to remember percentage is based off of grams if it's weight and ml if it's volume, okay? Continue.
So then 250 times 5 would be 1,250. And then divide that by 100, which equals 12.5.
Give me the full answer.
12.5 grams of dextrose.
Very good. So if you're asked and they didn't specify the word dextrose, how many grams of solute, then it's either sodium chloride or dextrose, okay? Good job. Nicole, your turn. Wait, somebody got kicked out. Miss Trisha? Tony? No, Robert got kicked out. Okay, continue.
So I put 10 grams over 100 milliliters. And then I put X grams over 250 milliliters. And then I cross multiplied to get 2,500 equals 100X. And then I divided the 100 by 2,500 to get 25 grams of dextrose.
Very good. So is it now clicking finally? It isn't that bad, right? Yeah, okay. I slow down here and I'm repetitive on this topic. Why? 2 cases that are familiar to you guys. Alyssa Shin's case, okay, which is the Summerlin Baby Hospital case. Emily's Law, okay. Emily Jerry, remember? Okay, Emily Jerry in Ohio. That was a sodium chloride, a normal saline, medication error because of wrong calculation. Okay, I don't want that on your head. I don't want that in your conscience. I don't want that on your shoulders. I want you to be able to sleep good at night. Okay, always double check, triple check your work. Tony, are you confident now?
Yeah, I knew as soon as you did the first one, I either did them all wrong or right, but I'm pretty good.
Yeah, so who got all 5 correct? Hands up. Okay. Robert, are you confident now?
I give it like an 80% confidence.
80%, that's fine. That's why we have more worksheets and we have more practice, and that's fine. That's totally fine. Okay. Any questions at this point? Okay. You got to continue on alligation. Alligation basis is percentage. However, it gets a little bit more complicated. And how does it get complicated? You have 2 strengths, a higher strength and a lower strength. And you have to mix some of the higher strength and some of the lower strength to make a middle strength. What do I mean by that? Say, for example, the drug is available in your pharmacy. The drug available in your pharmacy is for is 50% concentration or strength or solution and a 20% concentration, strength or solution. And you need a 30% middle. Oh my God, why would they even do that? Okay. Not very often do we have that problem anymore. Why? Because manufacturers are smart. They just create the correct concentration of the drug. Okay. However, if you work in a compounding setting, in a real manufacturing setting, these are problems that are commonly encountered because you don't always have the correct chemical or drug strength that's available in there, okay? And this topic, a lot of students struggle with, okay? That's why I'm very, very careful with this one. In my 12 years teaching, 11th year at Pima, okay, there were periods wherein 5 students at one time failed this class, okay? And I had tears, both male and female, okay? I've seen tears and I don't like that, okay? Not that I don't want you crying, it's just that it's hard because I keep telling you, I don't make your grades. You make your grades, I just record them for you, okay? So I try my hardest to teach you Alligation the simplest way I could, okay? But do not disregard or take for granted the resources that you have, like the videos, okay? Let's do a quick call. Eileen, how confident are you with percentages? So when we move forward, Alligation.
I'm good with this one.
Yeah, give me a percentage.
About 80.
80% too?
Yeah.
Okay. You have to be at 100% soon because Alligation is going to be more complicated. What about you, Tony?
Everybody's going 80, so I'm gonna underbid them. I'll go 70%.
70%. Robert said you're 80. You're still at 80. You want to change your answer?
You know, maybe now that Tony talks about it a little bit, I might have to go 69%.
Oh my God. You guys make me crazy. Okay, Kevin, what about you?
I'll probably stick like 85%.
85. Yeah, that's a good percentage. Okay, what about you, my freshman? Here we go, Jess.
I'll say 77% because it's still.
It's the passing. So she's confident that she's gonna pass this class. I like that. Okay, but we still have. This is just the first day of the 3rd week. You still have 5 days plus a weekend to get it up to 100 and learn Alligation. Ziri, what confidence level are you at right now with percentage?
A 70.
A 70. Okay, that's not passing for our standards, huh? That's a Clark County School District passing, not Pima's. Okay, what about you, Nicole?
A cool 80.
A cool 80. So I'm pretty confident that you guys are going to pass. We still got 1 week to go or 6 days to go. Okay, watch the videos. Watch the videos. Do the worksheets. Okay. Do you know that there was a quiz yesterday for math? That Ziri's face changed. There was an announcement on that one. There wasn't an announcement on that one, but I told you to look at your Tuesday folder last Monday, right? Okay. Prescriptions can be verbal order or written order. I was testing. Okay. I was testing if you'd open that Tuesday folder yesterday. And yes, there was a math test in that folder. Okay. 1 paper test. Okay. I mentioned that many times during the Zoom. Okay. Any questions? No questions? Ms. Trisha, I haven't seen you forwarding emails about lab schedule. We have to go back to forwarding to them lab schedule reminders. The students who will be in the campus plus Karen and the usual people that we email so that they know. Okay, again, Fridays 9 to 3 is only for Ivy. Okay, Ms. Trisha's available Mondays and Wednesdays from 3 to 5 before she starts her class. Okay, any questions? Any questions? Expect Friday to be 2 hours or almost 2 hours of math because I need to pump that class for you guys. Any questions? No questions? Come on. No? Done? Okay. I'll see you guys on Friday for another live class. Same time, same channel. Okay, bye.
You're not taking the day then, Miss L, on Friday?